Start with Amauri Gentil's talk. He's from AG Consulting. Have a great talk. You can introduce yourself. Good afternoon. My name is Amauri Gentil. I'm going to talk about thermoplastic elastomers. It's a trend of going from thermofixed materials, EPDM materials, to elastomer thermoplastic. The thermofixed are not recyclable, and the elastomer thermoplastic are recyclable. They process as plastic, so it's a rubber that is processed like plastic and has the same characteristics of rubber. It's a great innovation in technology for the automotive industry. First, I'm going to talk about what is a TPV. It's a thermoplastic vulcanizates in which we have a polymer matrix of PPE. A PP matrix and crossed links of EDPM. So we have a rubber with a plastic. That's why the name is elastomeric thermoplastic. I'm going to talk about a case that happens in the automotive industry. We call it glass run channel. It's this piece. If you don't know this part, it's where the glass is run in the doors. The four glass of the windows run inside this channel. How was it done in the past? This part in the past was made of rubber. Rubber is an EPDM. And where the glass ran, we needed a different type of material of polyester, of flock fiber, because the characteristics of rubber is to grip. And if you place glass in a channel like this, it's not going to glide or slide. That's why we did the EPDM rubber, and we applied a polyester flock fiber or a tape flocking or a cross-linked PE that had the reticulation process to run the glass. This all was replaced by TPV. Why? One of the major reasons, which is a trend of all the materials, thermofix materials, are to change to thermoplastic material, especially for recycling. And by recycling, I always like to stress that it's not at the end of the product's life. I talk about recycling during the production process. So when we're producing a material of thermofix material, like an EPDM rubber, all the scrap wasn't reprocessed because it's thermofix. After it's vulcanized, you can't put it back in the extruder. Thermoplastic material, when I mention recycling and regrinding, I'm always talking about the process. Because after this goes to the landfill, after 30, 40 years, it's going to mix with PP, PT. It's not going to become a glass run channel anymore. During the production process, all the waste, the scrap, will be ground again and put back in the production process. How was this part in the past? These little wires here are the polyester flock fibers. It goes inside the metallic channel, and that's where the glass runs. So the entire surface that is in contact with the glass needs this flock fiber on the PDM rubber. And what did we do in the automotive industry? We changed our process. What was the main evolution? We used a TPV in which you have 3 grades of material. So you're going to work with 3 extruders and 1 single matrix. And why do we have to work with 3 extruders? Because we're going to have 2 different grades, 3 different types of material. The material is expanded TPV, like foamed TPV, in which you have a reduction of mass. The other part of the same part is a dense, rigid TPV. And where the glass will run, we're not going to use polyester flock fiber anymore. We're going to use a low friction TPV. And when we do all that, after all that, we will have 3 hardnesses, 3 different materials running in that channel, and the adherence between them will be the melting point of the materials. So it will heat and adhere to each other, and we will have a very strong anchorage. So you don't need adhesive or anything, so you save a lot in the production process. I'm going to speak of some of the advantages of having a low friction TPV. It will offer excellent performance with very little waste. You will be able to do a better design that will fit better the vehicle's door. You won't have any gaps or deformed parts. Also, you will have a much better durability than a thermal fixed rubber. Additionally, in terms of sustainability, what are the advantages of using a TPV? TPV's density is lower than a thermal fixed part, so you will be able to reduce mass. The automotive companies want the car to weigh less and less to reduce mass and to consume less fuel. And with the density of a TPV of 1 gram per cubic centimeter or TPE of 1.15, it means 15% more mass on these parts. And they have a considerable volume in a car. What we can also say, you will have a steep reduction in the process area. The plant that makes a thermofix part and one of a thermoplastic part will need much less space. So you need less space to produce the same product. And that's also very important. And when you vulcanize rubber, you need high temperature. That means high cost to vulcanize rubber. So you're going to also reduce your energy consumption. These are the main advantages of a TPV when we compare to EPDM. The process is easier, extrusion is much shorter, injection and molding is much better. With TPV, that's a great advantage. A color standard. If you want red, a certain shade of red, or a certain shade of gray, you can standardize the color. With rubber, you can't get that. The color changes during the process, so you can keep the same color standard in the cars. Resistant to weather. We have instruments that simulate UV light, and you have a part in color. It holds the color and it doesn't fade. So the part doesn't fade or lose its color. It also has good chemical resistance, good processability, good UV resistance. The material is excellent for adherence, and also all the tests that we conduct in vehicles, the part can't exude oil. So inside a vehicle, when the external temperature is 40 degrees for about 2 hours, inside the vehicle there are some areas that are 105 degrees Celsius. And at those temperatures, they start releasing oil, like carpets, plastics. These oils are released and they condense on the glass. That's what we call fogging, and it fogs the windows and the glass, and you have distortion of image. Odor. If you get like that mat that you put over the rug, the smell inside the car is terrible. They have a terrible smell. TPV doesn't have any odor. It doesn't have VOCs. It doesn't have any blooming. It doesn't bleach. It has a soft touch. So if you have a button on the radio, the grip and touch are very good. So this material has many advantages. We were able to achieve hardness from 20 short A to 40 short D. So it's a wide range for polymers. The temperature goes from minus 40 to 130 degrees Celsius. So you can work inside the engine compartment, for example, where the air filter and the hose, you can use the TPV material there. So temperature up to 130 degrees is our normal working range. Excellent UV resistance to ozone, detergents, acids, fatigue, abrasion is resistance to good, and also the color standards. There are some things that are against it. It's not a perfect material for everything. What is the greatest problem of TPV? Since it has plastic in the middle, it has the characteristics of plastic. And the compression set And permanent deformation is much worse than rubber. And in some parts of the door, we have a bulb of sponge, a metallic core, and we use EPDM. We don't use thermoplastic. So for some applications, it's not going to work. Another application that doesn't work, I'm going to make parts of TPV because the deformation doesn't meet the requirements. When you apply load, it will deform. You have to be careful when you handle it. It requires careful handling because it deforms if you have any sharp edges when you're transporting it. So when you wrap it, it has to be wrapped in a paperboard so it doesn't deform. It also works at temperatures lower than elastomer. It's not going to reach 250 degrees Celsius like silicone. And the durability, the loss of angle, it doesn't meet those requirements. If you have a hose that will have oil and fuel, you're not going to do it with TPV because you have EDPM. It's not ideal for oil and gasoline. So TPV is for like air vent tubes, glass, and body seals. It's excellent for that. And some boots from the demi-axis. This is what I was saying. When we work with the glass run channel, where we have glass materials and expanded TPV, or dense TPV, or low friction TPV, we have two entries that go to one single matrix. And it has adhesion to the material. When it cools down, it's already anchored without the use of any adhesive. We also have legal requirements. When we say that, it's for any part of the vehicle. So none of the vehicle parts, even the EPDMs, can have odors, fogging. At the end of the vehicle's life, it has to be disassembled. So you have to be able to design it in a way that it's easy to disassemble the parts. Imagine a part that has metal together with plastic. You need to have a design when it's protected, so it makes it easier to disassemble. And crash tests. What I always point out are, for example, the panels on the side doors where you raise the windows. If it's pure PP, in the lateral crash test, it breaks. When it breaks, it can form sharp edges. If it does punch a hole in the dummy, that can happen. So you need to put the more flexible material that can be elastomeric material. Normally we use EPDM. So when we have the crash test and the door panel breaks, it's not going to create sharp edges. These are automotive regulations. If you do have any questions, please contact me by email or phone. And we have a booth of compostos. So if you want to learn more about TPVs, it's G70. Thank you very much. Thank you, Amauri.